Hey scientists, welcome back to Over the Top Science. I'm Mr. Crouch. In today's lesson, we're going to continue talking about solids, liquids, and gases. We're going to talk about changes of state, and we're going to talk about freezing and melting points, and condensing and boiling points. If you haven't done so already, please give me a click down there on the subscribe button. Let's get started. Alright scientists, let's start a new science journal page, and we're going to call the page Changes of State. Now, we learned in the last lesson that the states of matter are solid, liquid, and gas. So what changes of state is you're changing either from a solid to a liquid to a gas to a liquid, or a liquid to a solid. After you write the title, you're going to want to skip about 3 lines in your journal. Start up down here because we're putting some stuff up here later. And what we're going to do is we're going to start by drawing the states of matter like we did in the last lesson. So I'm going to draw the molecules of a solid. So, as I'm sure you recall, the molecules of a solid are very tightly packed, no spaces, because it maintains its shape, it maintains its volume. And I'm going to go ahead and do a liquid. I think we used orange last time, so I'll draw a liquid here. And remember that the molecules are loosely packed, some touch, some are kind of further away, and the liquid takes the shape of the container. So I'm just go ahead and draw a liquid here. And then the last one we used a red for a gas. Gas has the most energy, so we use red to kind of symbolize heat energy. And as you recall, some of them kind of went up here and whatnot. We also want to label it. So we use blue for solid, orange for liquid, the middle amount of energy, and red for gas, the most amount of energy. I told you in the last lesson, I'll tell you again, the most important thing to think about is think about the states of water, and that'll help you understand the changes of state and how you get there. Now, everything has its own solid and liquid gas state, but when you think of water, it's certainly something you can relate to. Alright, so let's start going through the changes of state that are possible. What if we want to go from a solid to a liquid? So I'm going to draw an arrow from a solid to a liquid. I have this one here just to show we're coming from a solid here. So how would you do that? So let's think about it again. I told you to think about the states of water. So what's solid water? Well, that's ice. How would you get from ice to water? Alright, so how would you do that? Well, first of all, you'd have to heat it in some way. So, well, let's try to sound more sciencey. So we could add heat energy, or make it warmer, or even more sciencey. What if we call heat energy thermal energy? So let's increase thermal energy, and that'll make the ice. What will the ice do? The ice will melt, and that process is called melting. All right, so it's the same thing. Now, how would you get from liquid to a gas? So I'll draw another arrow. And I want to show again we're coming from a liquid to a gas, so I'm going to kind of put this one here that I made. All right, so what would you do with thermal energy there? You want to go from a liquid to a gas. Yeah, that's right. You would increase thermal energy again. You have to make it hotter, so you would increase thermal energy. So when you have water and it turns to a gas, what's that called? Well, there's 2 ways of doing it. You can put it on a stove and you could boil it, or you could just let it sit there and have it evaporate. So either one of those would be good answers. So to get from a liquid to a gas, you could evaporate it or you can boil it. So the processes are evaporation and boiling. Alright, so reviewing what we did, we went from a solid to a liquid by increasing the thermal energy, and that's called melting. And then we went from a liquid to a gas by, again, increasing the thermal energy. And that could be either through evaporation, for example, like in a puddle, or boiling if you heat it on a stove. Now, what if you go the other way? What if you want to go from a gas to a liquid? So let's draw an arrow from a gas to a liquid. And I'll drag this one over here. Now, what would you do for thermal energy for that? would you do? Would you add cold energy? Well, there's no such thing. So how are you going to do the thermal energy? Yep, you would decrease the thermal energy. So that if you cool it, that's decreasing the thermal energy. So I'm writing it in blue because thermal energy is going down. And what is that called? That's called condensation. When you're going from a gas to a liquid, that's condensation. The root word of condensation is condense. And what condense means is to bring things closer together. So just imagine these particles going closer together. Well, when they go closer together, now your gas starts to look like a liquid. And that's what condensation is. You're condensing the molecules by cooling or decreasing the thermal energy. All right, so now we're going to go from a liquid to a solid. So think about going from water to ice. What would you do then? Well, you would do the same thing. You would decrease the thermal energy. And what is that called? If you want to go from water to ice, well, you would freeze it. So that's called freezing. We're going to continue talking about the changes of state. In many of the examples, I use water as an example of changes of state. Liquid to ice, liquid to boiling point. So we're going to talk about water temperature and the changes of state. So take a moment and write this title and go ahead and draw this empty table. Leave yourself some space, and I'll pause the video and we'll get to it in just a moment. Okay, did you draw the table? All right, great. So let's first talk about the freezing point of water. At what point does water turn from a liquid to a solid? And when you write freezing point, write in the top of your table, because later on we're going to write something down here. So put it up top. So at what temperature in Fahrenheit, Fahrenheit's what you're used to, at what temperature in Fahrenheit does liquid water turn to ice? All right, the answer is 32 degrees Fahrenheit. And the abbreviation for Fahrenheit is capital F. And when you write the number, you actually have to put a little open circle above the number. That means degrees. I couldn't do it on my program here, so I just drew it in. So 32 degrees Fahrenheit is the temperature in which solid ice becomes liquid water. All right, so now how about Celsius? Well, Celsius is always great because it always has easy numbers. So even if you don't know the answer, what's a nice low easy number? Did you guess 0? 0 degrees Celsius, nice and easy, is the freezing point of water. That's when liquid water turns to solid, liquid to solid. And again, you want to put the degree sign. And the abbreviation for Celsius is a C. All right, so now let's go to boiling point. And I'm going to write boiling point in red because that signifies a lot of energy, a higher temperature. So in Fahrenheit, it's a kind of a complicated number. What's the temperature in which water begins to boil and then begins to turn to a gas into water vapor? It's 212 degrees Fahrenheit. And put your little circle above to include degrees. And this time, let's just use an F to signify that it's for Fahrenheit, because it's easier and you can do that, and that's the known abbreviation for Fahrenheit. Now, back to Celsius. A nice and easy number for boiling point. So it's 0 degrees Celsius is freezing. The boiling point, nice easy number? Yep, 100. 100 degrees Celsius. Look at these easy numbers. Isn't the metric system great? All right, I have a question I want you to think about. The freezing point of water is 0 degrees Celsius and 32 degrees Fahrenheit. What do you think the melting point is? Write a prediction. So go ahead and write that question down, put it in your journal, and really think about it. Put some numbers in your head and see what state of matter would be at that particular temperature, and come up with a good prediction. Justify your response and be able to explain it. Go ahead and pause the video, think about it for a moment, and I'll be back with you in a minute. All right, so we're going to talk about Fahrenheit. Even though I like Celsius better, I want to avoid getting to negative numbers. So I'm going to write some degrees Fahrenheit down. So I'll put down degrees Fahrenheit. And I'm going to write these numbers down, and we're going to talk about what state of matter water is at that point. So we have 34 degrees Fahrenheit. We have 33 degrees Fahrenheit. We have 32 degrees Fahrenheit. And we have 31 degrees Fahrenheit. So if it was 34 degrees Fahrenheit outside, it'd be very cold. However, if there was a puddle outside, it would not freeze. So that puddle would still be a liquid. So let's say the temperature dropped a little. 33 degrees Fahrenheit, still really cold, but that puddle is still a liquid. Now we have 32 degrees Fahrenheit. So what would water that puddle be at that point? Well, that puddle would be a solid. It would turn to ice because we know that 32 degrees Fahrenheit is the freezing point of water. And at 31 degrees, well, it still would be a solid because that's even colder than 32. Now, think about it. Now it's 31 degrees. Let's say it gets a little bit warmer. It goes to 32. What's going to happen to that puddle? Well, it's going to begin to melt. So 32 is the point in which a solid becomes a liquid and a liquid becomes a solid. So the melting point and the freezing point of water are always the same. So let's write that down. Were you close? And what I'm going to do here in the table, remember I asked you to save a space? I'm going to put the word melting point under the freezing point. So the freezing and melting point of water is 32 degrees Fahrenheit, 0 degrees Celsius. So I have my wife's solid gold necklace here. I'm a teacher, so every week when I get my paycheck, I go out and buy my wife a new solid gold piece of jewelry. Now, let me ask you, can this be melted? Well, freezing and melting points are the same. So what do you think the melting point of gold is? Do you think it's 32 degrees Fahrenheit? 0 degrees Celsius? No, that's the freezing and melting point of water. Remember, only water has that freezing and melting point. This melting point is 1,948 degrees Fahrenheit, or 1,064 degrees Celsius. Wow, that's a lot hotter than water, isn't it? Yes, it is. So every substance has its own unique melting and freezing point and its own boiling and condensing point. So let's go back to our table. Let's make a table here and let's talk about some freezing and melting points of various substances. Take out your science journal. All right, so we're going to draw a table. The table has 3 columns and 4 rows. It has a title of freezing and melting points of substances, and it has these labels here. I put the freezing point down here. It really belongs up here, but it didn't fit very nice. It's not typical to put it down here. It's fine for this purpose here. So go ahead and take a moment and copy the table down. Pause the video, and we'll get started when you're ready. Okay, you ready? All right, I'm going to put water in the table again. You do need to know the melting and freezing point of water and the boiling point of water. You do not need to know the melting point of gold or anything else we talk about, but water you definitely should know. So what is the melting point of water? Well, it's the same as the freezing point, right? So what is that in Fahrenheit? Do you remember? Yeah, it's 32 degrees Fahrenheit. And make sure you put your little circle here. And what's it in Celsius? Remember that nice easy number? Yep, 0 degrees Celsius. And then we just talked about gold. So let's fill that in. So gold is 1,948 degrees Fahrenheit and 1,064 degrees Celsius. So that means if we take the gold necklace and we heat it to 1,948 degrees Fahrenheit, you could turn it into a liquid. And then they actually do this. And then if I wanted to melt this down and turn it into something else, maybe I could turn it into a couple of bracelets or something else. Then they would heat it and they would put it in a liquid and they would cool it to be below 1,948. Then it would freeze and then you would have 2 bracelets instead of 1 necklace. So think about that. So literally this necklace here is a solid, so it's frozen. right? Yeah, it is. All the solids you see are in their frozen state. This has been a pretty long lesson. I'm actually getting pretty hungry. Do you guys mind if I go get my snack? I'll be right back. I wonder what solid and liquid my wife packed me today. She packed those snacks today. Some days I do it, some days she does it. So usually she gives me a water, which I love water. Water's good for you. And an apple or nuts. Let's see. Yep, water. Score! Oh my God, she gave me a Hershey bar. So Hershey bar is my solid and water is my liquid. Do you guys mind if I eat the Hershey bar? See if we can get this thing open here. Here we go. Got it open. Pretty excited. As you see, the Hershey bar is a solid. So this really looks delicious. Wait, what's going on here? I got all chocolate on my fingers. Why is that? It was just solid a moment ago. It's not that hot in here. My laboratory is 74 degrees. So this was a solid when I opened it. And now it's beginning to melt on my fingers. Why is that? Now, I want you to think about it for a moment. Why is the chocolate melting on my fingers? And it wasn't melted when I opened it. So take a moment, pause the video, and write a prediction on why the chocolate melted in my fingers. And why, I'm sure that happens to you too, doesn't it? All the time when we eat chocolate bars. It always melts in our hands. Alright, so what'd you come up with? Alright, let's think this through. When I opened the chocolate bar, it was a solid and it wasn't melting. We also know it was 74 degrees here in the lab. So I began to eat it and it melted in my hands. So it must have something to do with me. So what's my temperature? Well, we know the average human body temperature is 98.6 degrees Fahrenheit, 37 degrees Celsius. You know this because when you go to the doctor and you're sick, he or she scans your forehead or puts a thermometer in your mouth and takes your temperature. And if it's 98.6 degrees Fahrenheit or close to that, he says you're well. If it's higher than that, he or she says you're sick. So it must have something to do with that 98.6. Well, it melted in my hands. So is the melting point of chocolate less or greater than 98.6? Well, it has to be less than 98.6 because it began to melt. And it has to be greater than 74 because that's the temperature in here. Well, I'm going to tell you now. The average melting point of chocolate is 86 degrees Fahrenheit, 30 degrees Celsius. So that's why it melts in your hands. All right, let's go back to our journal and update our journal. All right, so let's update our table inside our journal. We just figured out the freezing and melting points of chocolate. So let's put chocolate here. And we said it was about 86 degrees Fahrenheit and about 30 degrees Celsius. See, I'm putting about because foods are not absolute. First of all, they're made out of different ingredients. Every chocolate bar is made out of different ingredients. And fat content kind of changes the game as well. Things like gold have an absolute one, but food products do not. All right, you see I left an empty row here. Well, that's for you to fill out. So your job now is to find another substance and find its freezing and melting points in both Fahrenheit and Celsius. Now, just getting back to the table, you do not need to know the freezing and melting points of gold, chocolate, or probably whatever you do here. You do need to know the freezing and melting point of water and also the boiling and condensing point of water. The only reason I put these here and we're doing this is to illustrate that every substance has its own unique freezing and melting points. Okay, here's an investigation you can complete either at home or in the classroom. You'll need 3 ice cubes, 3 identical cups or glasses, and a thermometer. Go ahead and pause the video and gather the materials that you need. Okay, here's an investigation you can complete. All you'll need is 3 ice cubes, 3 identical cups or glasses, and a thermometer if you have it. Please pause the video and get the materials that you need. Okay, scientists, that does it for today. If you have any questions or comments, please email me at overthetopscience@gmail.com. Please, if you haven't already, please subscribe to my videos below. And happy science, everyone.